Hello. Today we're going to be looking at fraction operations. Fraction operations is chapter 3b, so fraction operations. You can write that on the top of your book. Now, it's quite a bit to cover since we'll be covering how to use fraction operations, uh, plus, subtract, multiplication, and division. It's a big chapter to cover. What you do want to remember is that there's two separate ideas here. We can categorize this by putting addition and subtraction probably in one category and multiplication and division in another category in terms of how the techniques and the procedures work regarding this. Let's take a look at some key ideas with this before we start going into the examples. Here we can see that when we add or subtract fractions, we should already have some idea of this because we learned this in grade 7. But when you add and subtract fractions, you need to ensure that the denominator or the bottom number in the fraction are the same before proceeding. If they're not the same, you can't perform the addition or subtraction just yet. What you will need to do is using your knowledge of equivalent fractions, which we did last week, find a way to ensure that both denominators are the same by either multiplying both sides of one fraction by a number or dividing both sides. Sometimes you can get there with a variety of different strategies. We'll find them as we go through our examples, but that's what we do for addition and subtraction, for subtracting fractions. You probably want to write this down on your book somewhere that denominators, this is what you should be copying down, denominators must be the same before you can proceed with adding or subtracting fractions. You can pause the video here, write that line in your book because it's very important. That is the key thing that you need to know when adding and subtracting fractions. When you get the denominators to be the same, the only thing that changes is that well, your answer will still have the same denominator, but the only thing that changes is the top numbers or the numerators add together or subtract depending on what you have. Okay, now multiplying fractions is a bit different. When you're multiplying a fraction, you don't need to have the denominators the same. So you can even write that here, but if we can look at multiplying fractions, denominators do not need to be the same before you proceed with fraction multiplication. Okay, all you have to do is simply copy this down too. Simply multiply the numerators together and then multiply the denominators together. Okay. The best thing to do when you have a mixed number, if you don't know what a mixed number is, if you have a mixed number like 3/4, that's a mixed number because there's a whole number and a fraction. The best thing you can do there is actually convert it to an improper fraction beforehand. Right? This is mute. This is multiplying fractions. Dividing fractions is the same in the same way of, I shouldn't say the same, they're quite different, but there is a something we can do, a special technique we can do to convert the division into a multiplication, and that's what we need to look at. Once again, for dividing fractions, which I highlighted up here, you can write down denominators do not need to be the same before you proceed, okay? But what you need to be able to learn is something called the reciprocal of a fraction. The reciprocal of the fraction is almost like reversing. You're just swapping the numerator for the denominator. So the reciprocal of, say, 3/4 is actually just 4/3. I'm just swapping it over. When you're dividing fractions, what you need to know is that you're just, instead of dividing the fraction, you can actually swap it so that you multiply the reciprocal. That's a special technique. I'll give you a way to remember that a little bit later. But this is a really good thing to keep note of, just so you have it in front of you. Here is some good summary. Adding and subtracting fractions is what you do. Multiplying fractions is what you do. Dividing fractions, that's what you do. So let's try this in some examples. So let's look at adding and subtracting fractions. The first one's super easy because what was the first rule I said when it comes to adding or subtracting fractions? I said that the denominators have to be the same. Here, they're already the same. So all I have to do is write equals, just like we did for the order of operations. We're writing the equal sign underneath the question. So we write the question down first, then we write down the answer. 3 over 5 plus 4 over 5 is 7 over 5. Whoops, don't know why I did that. 7 over 5, because 3 plus 4 is 7, and then the 5 stays the same. The denominator actually stays the same at the bottom. All right, let's take a look at the second one. 5 over 3 minus 3 over 4. Here, the problem is, we should hopefully be able to see the problem. Denominators are not the same. So we need to find a way to find, funnily enough, the uh, lowest common multiple of 3 and 4. Why do we need to do that? It's because we need to find a way to multiply both sides. So here, what we can do, a special trick you can do here, sometimes there's a better way to do this depending on what the lowest common multiple is. But here we can simply go multiply the other side, multiply both sides here. So I'm going to multiply 5 and 3. Make sure you remember to get equivalent fractions, these two have to be multiplied by the same number. I'm going to be multiplying it by the opposite denominator. So let's take a look. This is the denominator on the other side. I'm just multiplying the other fraction by the opposite denominator. And then I'm doing the same thing here, multiplying the opposite denominator. Here I have 3 and 3 because this is 3. Okay, why that works is because if you look what happens, 5 over 3 times 4 on both sides, and make sure you have the times 4 on both sides. It's really important that you do that. Becomes 20 over 12 minus 9, because 3 times 3 is 9, 4 times 3 is 12, and look at the denominators. Nice and clean and same. 20 minus 9 is just 11 over 12. Notice how the denominators stay the same. Okay, that's how you do addition and subtraction of fractions. Very straightforward. Denominators have to be the same. I'll say it again. Denominators, if you have written this down already, have to be the same. Okay. Next, adding and subtracting mixed numerals. Okay, so taking a look over here, I need to actually move some stuff away. I have to do this to create some more space. I'm going to do one of these same time. The main thing you need to know, and I said this before, is that, well, first of all, you got to write the question down. Okay, this plus 2 over 3. Oh, sorry, no, it's not. It's 2 and 3/4. The first thing you need to do here is convert both into improper fractions. To convert it into an improper fraction, you got to think about it this way. What I'm going to do is I'm thinking, okay, I know that the fraction's going to be, the fraction has to have a denominator of 8 because this has a denominator 8, okay? Now what we have to do here is we go 3, so this big 3, times 8 plus 5, okay? 3 times 8 plus 3, sorry, it's times, so this is times. 3 times 8, because there's 3 lots, 3 holes, 3 lots of 8, plus the extra 5. So that becomes 24 plus 5, which is 29. And then this, and then we do plus, and we do the same thing on the other side. Remember, the denominator has to stay the same, so this has to stay 4 at the bottom. And once again, I'm doing this arrow thing, so this is 2 times 4 plus 3. 2 times 4 plus 3, which is 11. Okay, and then here is where I can demonstrate to you that sometimes you don't need to cross. Remember before when we were doing here, we were timesing the opposite denominator. Look at here. If you're looking clearly, your times tables are good. You can see that I don't need to do that. I can just times this by 2 and times this by 2, right? Because what happens if I times 4 by 2? It comes to 8, which is what the opposite denominator is. And the goal is to get the denominator to be the same. So here I have 29 over 8 still, plus 22 over 8, which is equal to, well, the denominator stays the same, so the 8 stays at the bottom. 29 plus 22, which is 51. Okay, and then what did it say? We actually could convert this back to a mixed numeral. If you want to know how to do that, Here's how you do it. Okay, you think how many eights are there in 51? Okay, so you go, 4 eights are 32, 5 eights are 40, 6 eights are 48, 7 eights 56. So too many. So 6 eights are 48. So six has to be six wholes. 6 eights are 48, and whatever's left over, which is 3/8. Okay, that's how you convert it back to a mixed number. All right. So let's take a look at fraction multiplication. Okay, fraction multiplication is really easy because all you have to do, remember, although you do have to remember, you have to simplify at the end. Okay, what you can do here, 2/5 times 3/7. Okay, what you can do here is you can go 2 times 3/5 times 7. And that is 6/35, and that's your answer. You can ask, you can think about it. Can we simplify this? Can we divide both sides by 2? Divide both sides by 3? No, we can't. We can divide 6 by 2 and 3, but we can't divide 35 by 2 or 3. So this is the simplest fraction. Okay. The second one's a bit interesting. I'll show you why. Because there's a special trick you can do in fraction multiplication that you may never have seen before, but I'll show you. You can do this before, so you don't have to simplify this massive fraction later on. Okay, I like to call it the butterfly method. Basically, I'm looking at these two numbers and I'm looking at these two numbers, and you can see that sort of creating butterfly wings there. Okay, the reason I'm looking at these two numbers, and I won't use the red because it's a bit too much. I'm looking at this pair and I'm looking at that pair. I'll use a different color maybe, and I'm going, okay, well, 8 and 4. Can I simplify that? 8 and 4. Yes, I can. I can divide both sides by 4. Okay, I can divide both sides by 4 like this. Okay, so this becomes 1, this becomes 2, and now if I just multiply them together, 2, so I'm doing 2 times 7, because I've cancelled that 8 into a 2, divided by 4, and now I'm doing 5 times 1, which is equal to 14 times 5. If you don't do that butterfly step, you'll get this massive fraction like 56/20, and then you'll have to simplify it later on. When you can just simplify it earlier, makes it a lot easier for yourself. So I recommend learning this technique early so you can do this, and we'll keep practicing this. We'll take probably 2 lessons on this chapter. Okay, let's take a look at the final thing about dividing fractions. I'll do that other question possibly later. Okay, let's take a look. 2/5 divided by 3/7. Okay, now you may not have remembered what we did before, but I'll tell you, what you can do is 2/5. You can convert this into a multiplication question. So we're just going to multiply by the reciprocal of 3/7, which is the reverse. Okay, and then this is just 2 times 7 at the top, 5 times 3 at the bottom, 14/15. There's your answer. Okay, there's a simple way that I like to use to remember this. I call it KFC. Okay, it's a bit funny, but here's what happens. KFC, because keep, flip, change. I want you to write this down in your book so you can remember this. Okay, what does this mean? Okay, when I do a question like 2/5 divided by 3/7, just the same question. Okay, what happens on the next line? You keep the first fraction. Okay, this fraction, you keep it. You flip the second fraction. Okay, so this becomes flipped, and then you change the sign. So divide becomes multiply. That's how keep, flip, change works, or KFC works. So if you divide a fraction, as soon as you see divide, KFC, keep, flip, change. Okay,